Hey guys, welcome back to my channel. So today let's talk about entity fixed effects regression models. When you have panel data or longitudinal data, we should use fixed effects because if your purpose to find a causal relationship between X and Y, you better to control for a lot of confounding variables, right? So by using panel data, by doing fixed effects, we can actually control for a lot of confounding variables without even collecting the value of those variables, without even observing the variables. So we can control for a large groups of variables that might confound the situation, okay, by doing fixed effects. So without further ado, let's get into the video, right, to see how can we use fixed effects, entity fixed effects model to control for the variables that are constant over time and differ across entities. Okay, so let's get into it.
FE regressions. F stands for fixed and E stands for effects. So fixed effect regression models look like this. So Y subscript IT equals B0, right? Y-intercept, right, plus B1 X sub IT plus B2 Z sub I plus error. And this is called entity fixed effect regression model. So suppose there's only one regressor X. And this Z sub I varies only with entity, does not vary with time. So we call this entity fixed effect. If it's time fixed effect, it will be like this. YIT equals B0 plus B1 XIT plus B2. It just use different letter to denote time-specific characteristics. So it's S sub T plus error. Okay, I forgot T here. IT. So you see this variable with only one subscript T, that means this variable changes over time for each individual, but constant across entities. Okay, so we call this time fixed effect regression models. Okay, time fixed effect regression models. You see, I'm using this subscript IT. That means this. If you want to run a fixed effect regression models, you should have panel data or longitudinal data. For this video, let's just focus on entity fixed effect. Let's see how does this work. Okay, how this model works. Why do we say that we can use entity fixed effect regression model to control for all the unobserved individual specific characteristics or entity specific confounding variables? So let's look at this model, entity fixed effect, where we mainly talk about this model in this video. Let me just give you an idea of what the data look like. Okay, so suppose I 1 2 3 4, sorry, so this should be a panel data, right? So that I 1 1 2 2 3 3 4 4. Suppose T is time, T is 2. So that time 1 2 1 2. And I suppose Y sub IT, that's test score for each entity, right? Suppose I have 100 students in the data set, and that means I have 100 entities. We call this each entity or each individual or each subject, right? So YIT, that means test score for each student, each time period. You see, for each student, I collect the data for 2 points in time. Right, for each student, for each entity or each subject, I collect data for 2 points in time. I collect student number 2's test score in year 1 and year 2. Right, and so I can write this Y 1 1 Y 1 2. Right, test score second student year 1, test score second student year 2, test score third student year 1, third student year 2. Another variable X, and I just use X as study hours, how many hours you study per week. So study hours for first student year 1, first student year 2, study hours second student year 1, second student year 2, third student year 1, third student year 2, fourth student year 1, fourth student year 2, and etc. Like this. So now I have another variable here, right? This is a key. So the Z sub I just use here, Z sub I. You see there's only one subscript. That means the value of this variable does not change with time, right? It does not change over time for each individual. So I can write this for student number 1, the value of z is z1. Number 2, even if it's a second time period, right? Even if it's in year 2, the value of z stay the same. So that's z1. Student number 2, z2, z2. You see, stay constant over time. Stay constant over time. Stay constant over time, but differ across entities, right? Differ across individuals. And the value of this variable, the value of z, constant over time. So let me write here. Right? So the value of this variable z, constant over time for each entity or for each individual, but it varies across entities. That means if we have panel data, we can control for all the variables that have this characteristics. Okay, we can control for all the variables that are constant over time for each individual, but differs across entities. Okay, we call this individual specific characteristics. For example, some other variable that affect test score and also correlated with the study hours, right? So check out my video before about panel data, a difference between panel data and cross-sectional data, time series data, and check out my video before about omitted variable bias. Okay, so you want to mitigate omitted variable bias in B1. So you want to control for all the confounding variables. If you have panel data, you can control for all the entity-specific confounding variables. Okay, so for example, in this case, the z could be how strict the parents are or the parents' education. If you run this regression, let me just give you the base case. Base case is yit equals b0 plus b1 xit plus error. So this is base case. You see, you're not control for any confounding variables. Again, your purpose is to find the causal relationship between study hours and test score. Okay, you want to interpret this B1 as a causal effect of additional study hour on test score. You want a B1 to have a causal interpretation. If some variable in error term correlated with X, we say this omitted variable. And if you omit this variable into regression, B1 will be biased. We call this bias, omitted variable bias. We say the B1 suffers from omitted variable bias, right? The variable could be Z sub IT. So the variable in error term correlated with X. Check out my video about omitted variable bias and causal inference. Okay, so if this variable, we call this confounding variable, right? If this omitted variable does not change over time, right? Z sub I does not change over time, stay constant over time, but differ across entities, and then we can control for this variable without even observing it. So we don't need the value of this Z. We don't need this value. So as long as this variable constant over time for each entity varies across entities, we can control for it using panel data. And here is how. Suppose I equals 1, t equals 1. And then we plug this into this regression. Okay, you get this y11 b0 plus b1 x11 plus b2 z1 plus error. Same individual, but t is 2. We have this y12 b0 plus b1 x12 plus b2 z1, right? Individual specific characteristics. So the z could be, again, the z could be how strict the parents are, right? Parents' education level or income, or sex, even sex or gender, right? Stay the same over time for each individual, but different for different student, right? Sex, parental involvement. If the student parents are very strict, and then the student probably will spend more time studying, and then their test score will be affected, right? So sex, parental involvement, income, students' innate ability. So those things are student-specific characteristics, can be controlled for using entity fixed effects. Okay, so now let's continue. So if let me just leave a blank. So if I equals 2, t is 1, and then you have this y2, 1, second student year 1, b0 plus b1 x2, 1, plus b2 z2 plus error 2, 1. Second student t is 2, so you have this y2, 2, b0 plus b1 x2, 2 plus b2 z2 plus error 2, 2. Right, all the way you can do, suppose there's 100 students, you have 100 pairs of regression equations. So we can control for this variable z by doing, here is the key, or here is the game changer. So you can control for variable z by doing the difference. So we just use equation 1 minus equation 2. You have this y11 minus, I just use right here. You have this y11 minus y12. Can I just zoom in a little bit? That equals, you see, there's no y-intercept, right? No b0 because cancel out b0 minus b0. We just use equation 1 minus equation 2, right? And b1 times x11 minus x12 plus, you see, you cancel out this term. This is a confounding variable, individual specific confounding variables like sex, parental involvement, income, ability will be canceled out, right, by doing the difference. And then you plus error 1, 1 minus error 1, 2. Right, you can just use a more general form, so that changing y for individual 1 over time, right, the changing test score between 2 years for the first student equals b1, which is the effect of x on y, right? Effect of study hours on test score. And the change in x, and this in parentheses is a change in x, change in study hours over 2 years. The difference in study hours between 2 years. So that's for first student over time, plus change in error, first student over time. Look at this equation. Right, there's no z because z is got controlled for. You take z, this individual specific characteristic, into consideration. But when you run the regression, you don't need it because you do the difference. Right, same thing. So this is equation 1, this is equation 2. 1 minus 2, you get this y21 minus y22 equals no b0. b1 x21 minus x22 plus, got to cancel out again. You got to cancel out this confounding variable. So that's why we don't need the value of this variable z. And then you plus mu21 minus mu22. And then you get this change in score between 2 years, right? For second student equals b1 change in x2t plus change in error 2t. So you can, each student you have this difference because t is 2 in this case, right? And then you can generalize to find the regression. So more general form is changing y it equals b1 changing x sub it plus error. So now this is entity fixed effect regression model, and this b1 is called entity fixed effects OLS estimator of or for beta 1, the true effect of unit change in study hour on test score. So we call this entity fixed effect estimator. So our base case, our reference point, our base case is this, right? You're just using this OLS regression. You're not control for any confounding variables. You just regress score against study hours and attribute all the other determinants of score to this error term, right? So now this B1 is called OLS estimator of beta 1. So this is an entity fixed effect regression model. We call it conceptual or reduced form. Basically, you don't need to observe this variable z as long as the z constant over time for each entity and differ across entities. Because when you do the difference, you can control for it. You can just subtract the z. Right? Once you do difference, you can control for it without observing it. So now B1 is entity fixed fact estimator. Yeah, this is an entity fixed fact when t is 2. If t is more than 2, we use the same method. We just use d-mean method. We'll talk about that in next video. But here there's a basic idea of how do we control for unobserved individual specific characteristics, or how do we control for individual specific confounding variables without observing any value of this variable. In next video, we'll talk about entity fixed effect when t is greater than 2.
Hope you find today's video helpful. In next video, I'm going to talk about entity fixed effects with time more than 2, okay, more than 2 points in time. So basically, we do the same thing. So I'm going to leave that to the next video. And any questions, please let me know, and see you next time. Bye.